Hello students, today we will discuss electric flux. In previous class we learnt about the electric field lines and electric field. So here the electric flux the, is the number of electric field lines crossing a unit area placed normal to the electric field at a point is called the electric flux. So we know that the electric field lines properties. Electric field lines are started from positive charge, ends at negative charge. So here the electric field lines, like here, okay, these are the electric field lines. This electric field lines is arrow mark is nothing but, so here it is ends at negative charge, here it is consist positive charge. Here the electric field lines is crossing a unit area. So for example, we consider a unit area. The area is like here, this is and certain area. Okay, this is certain area. So area is delta S. The electric field strength is E. So the electric field lines 1, 2, 3, 4. 4 lines are crossing through delta S. So then it is called the electric flux. So here the electric flux is taken as delta pi equals to E into delta S. So this is delta pi. Delta pi is nothing but, here pi is nothing but electric flux. Okay, electric flux is nothing but the number of electric field lines. How many number of electric field lines are passes? So these 4 electric field lines or passes is crossing a unit area placed normal to the electric field at a point is called the electric flux. This electric flux is denoted with pi. Okay, and units, SI unit for electric flux is, that is, so what is the here, Newton for coulomb. Okay, and here the area is meter square. So then Newton for coulomb for into meter square. So this is a SI unit for pi electric flux. So now we are consider this is normal. Okay, this area is normal to the this E. Okay, that is electric field. Now we are consider, so another electric field. This is another electric field. This electric field is consist electric field. Okay, here it is when we consider a particular area is, this is particular area, this area is delta S. Okay, and it is consider here, this is normal, so normal to the area. This angle is, okay, the angle makes with, and so this is another electric line, field line, this is angle theta. So then here delta pi is taken as E dot delta S. Okay, It is also taken as delta pi equals to E delta S into cos theta. Okay, so then the net electric flux pi equals to, so we can integrate both sides, that is integration of delta pi equals to integration of E delta S cos theta. Okay, then the total electric flux pi equals to integration of E delta S cos theta, or delta S is also written as pi equals to integration of E ds cos theta. ds is nothing but change of, okay, very small change of area. So then pi equals to integration of eds cos theta. This is about electric flux. So for example, we are consider a pipe. This is a pipe. When a pipe through the pipe, the water is moves like here. The water is moves. Okay. So what is the area? Area is A. Area of the pipe is A, is here, and the velocity is V. Then the flux of water flux is pi equals to area into speed. Okay, area into speed. So this is the water flux. But we are consider electric flux. Electric flux is nothing but the number of electric lines. Okay, so here water is in the place of water, so we consider electric field here. Okay, electric field, this particular electric field E. So the electric field lines crossing, the number of electric field lines are crossing through the unit area. That particular unit area we consider here 1 centimeter square or 1 meter square, like so. A unit area placed normal to the electric field at a point is called the electric flux. So this is about the electric flux. So next topic is electric dipole. Electric dipole is nothing but an electric dipole is a pair of equal and opposite charges, that is plus q comma minus q, are separated by a distance 2a, is called the electric dipole. So for example, this is plus q, this is minus q. Okay, equal quantity or opposite charge. Okay, plus q minus q, these are the points charges. These point charges are separated. Okay, these point charges are separated at distance 2a, is called the electric dipole. In this electric dipole, so here it is a midpoint of electric dipole is O. Now the what is the total charge of this electric dipole? The total charge of electric dipole is plus q plus minus q. So total charge is 0. So total charge of the electric dipole is 0. But the total electric field of the dipole is not equals to 0. So the net electric field strength electric field strength, or intensity of electric field is not 0. Okay, so this electric dipole moment, so electric dipole moment is nothing but the product of charge and the distance between charges is known as dipole moment. This dipole moment is denoted by P. So P equals to, okay, charge into distance between the two charges. So what is the distance between two charges? 2a. And what is the charge? So charge is q. So this is called the dipole moment. P equals to 2aq. So units of this, it is a scalar quantity, but it is written as vector quantity P bar equals to 2aq into P cap. So here P cap is a unit vector. Is a unit vector. So P bar equals to 2aq P cap. So this is the direction of the electric dipole, either positive plus q side or either minus q side. So this is the direction of the electric dipole. So here SI unit of electric dipole is, so what is the SI unit of electric dipole? So electric dipole moment, units are, it is distance into charge. So charge into distance, coulomb meter. So this is the units for SI units for electric dipole moment. Now can discuss the electric field due to electric dipole moment in a uniform electric field, that is at certain angle and at equatorial, okay, at equatorial point and at axial point. So these are the three cases for the electric field. Okay, the electric field strength of the electric dipole. For the first one, the electric dipole in a electric field strength, in a electric field, it is suspended with an angle theta. Then what is the torque? Torque means electric dipole moment. So this is electric dipole moment for the couple, a moment of couple. And again the electric dipole, the electric field strength at axial line and the equatorial line. So next topic is the electric field strength of an electric dipole. The electric field strength of an electric dipole, that is pair of charges at any point in a space, can be found out from combination of Coulomb's law and superposition principle. Okay, now first one, so we consider the first one, the electric dipole in a uniform external field, or it is also called the moment of couple, moment of the couple. So here we consider an external electric field. Electric field, that is E is the electric field. This electric field, and we consider AB is the plus Q and minus Q. It is separated by 2A. Okay, this dipole is make an angle theta at this point. Okay, now the force on the, so on point A it is F, so at point B it is opposite direction, the force is opposite direction, that is minus, so that is opposite direction of F. So because it is minus Q, so this is plus Q. Okay, so now we consider equal and opposite charges plus Q and minus Q is separated by 2A. It is called the electric dipole. These two equal and opposite charges constitute is called the couple. Okay, these two equal and opposite forces constitute a couple. So these couple of forces are equal and opposite direction. So what happens, for example, this is a dipole. So this is dipole in the external field. So equal and opposite forces, so it is rotate anti-clockwise direction. Okay, it is like a clockwise direction, it is moves like a clockwise direction. So then this couple rotates the dipole in a clockwise direction, So now then this moment of couple is also called the torque. Okay, so equal and opposite forces is occurred on the electric dipole due to the electric field. So then this moment of couple is also called the torque. So then torque acting on the dipole, electric dipole, so it is denoted by tau. So tau bar equals to, so here force into perpendicular distance between forces. So what is the perpendicular distance? This AC is the perpendicular distance. So then torque tau bar equals to force. What is the force? F equals to Q. Actually force here, force into perpendicular distance is AC. So this is equation number 1. Okay, so now the force F equals to, actually the electric field, from the definition of electric field strength, E bar equals to F bar by Q. Okay, from this equation F bar equals to Q into E. This is equation number 2. And again triangle ACB or ABC triangle ABC. The angle is makes at B, then triangle ABC. So here cos sin theta equals to opposite side by adjacent side. So then opposite side by hypotenuse, that is AC by AB. Okay, sin theta equals to AC by AB. So then AC, we want to AC equals to AB sin theta. So what is AB? The distance between two opposite charges. So then AC equals to 2A sin theta. This is equation number 3. Okay, equation number 2 and equation number 3 is substitute in equation number 1. Equation number 3 and equation number 2 is substitute in equation number 1. So then tau bar equals to, so what is the force? Q into E bar into 2A sin theta. Okay, so here tau bar equals to, so it is also written as 2AQ E sin theta. Okay, so now tau bar equals to 2AQ is nothing but P. Okay, moment of dipole moment. Okay, dipole moment P E sin theta. So it is also written as tau bar equals to P bar cross product here E bar. Already we learned in P1 vector product of, that is AB sin theta equals to A bar cross B bar. So here also it is from this equation. So then AB sin theta, PA sin theta equals to P bar cross E bar, that is tau bar. So this is the torque. Okay, torque on dipole in a external electric field. So now next topic is electric field due to the electric dipole. Set a point on axial line of electric dipole. So this is electric dipole. We consider electric dipole AB. At A point minus charge minus Q. At a B point it is plus Q. So these are separated by 2A distance. So this is O is the center of point. So here the axial line is nothing but, axial line is a line joining the centers of two charges forming an electric dipole. Okay, the line joining at a point. Okay, so these two charges and center of point, center of this dipole is line joining. C is the axial line. So we consider C is a point on axial line at a distance r from O. Okay, now the electric intensity, okay, electric field intensity or electric field strength at C point due to the positive charge it is E plus Q. This is this direction, left side direction, and E minus Q, okay, E subscription of minus Q is the direction of the, this direction, it is opposite direction of E plus Q, and also here it is due to the negative charge minus Q. So then the electric field intensity, electric field intensity E plus Q due to plus Q, okay, plus Q charge, that is E plus Q is written as equals to 1 by 4 pi epsilon naught into Q by, so what is the distance here from B point to C point? So the distance is BC square. So into, so we have taken here the vector quantity. So then here P cap is unit vector. Okay, P cap is unit vector here. This is P is in this direction. Now, so BC equals to E bar plus Q, E bar equals to 1 by 4 pi epsilon naught into Q by BC square equals to, so this is R minus A whole square into P cap. This is equation number 1. So this is from BC equals to, okay, OC minus OB. So what is OC? R. Okay, here BC equals to OC minus OB. Okay, so now this is equation number 1. Next, second one, electric field intensity, okay, electric field intensity E minus Q due to minus Q charge. Okay, so it is E minus Q bar equals to 1 by 4 pi epsilon naught into Q by, here Q by, so what is the distance here? So from this point to this point, AC square into P cap, so that equals to 1 by 4 pi epsilon naught into Q by AC square equals to R plus A whole square into P cap. So here, since AC equals to OA plus OC, that equals to A plus R. Okay, so this is E minus Q. Actually, what is the direction? This is opposite direction, so it is taken as negative. Equation number 2. Okay, now total electric field at point C. Okay, that is E bar equals to E bar plus Q plus E bar minus Q. Okay, from the equation number 1 and 2, so then we can get E bar equals to 1 by 4 pi epsilon naught into Q by R minus A whole square into P cap plus 1 by 4 pi epsilon naught, so this is minus, okay, into Q by R plus A whole square into P cap. So it is common here, 1 by 4 pi epsilon naught, again Q into 1 by R minus A whole square minus 1 by R plus A whole square, so into P cap, that equals to Q by 4 pi epsilon naught into, so the LCM is R minus A whole square into R plus A whole square. So now remaining is R plus A whole square minus R minus A whole square into P cap, that equals to Q by 4 pi epsilon naught into we can simplify this equation, R square plus A square plus 2AR minus of R square minus A square plus 2AR divided by, so this is like A minus B into A plus B whole square, so then R square minus A square whole square into P cap, that equals to R square gets cancelled, then A square gets cancelled, so here remaining is 2AR 4AR 4AR Q divided by R square minus A square whole square into P cap. Okay, so this is E bar equals to, so it is written as, okay, 2AQ into 2R divided by R square minus A square whole square into P cap. Okay, understood? 2AQ into 2R equals to 4ARQ. So 2AQ equals to P bar or P, electric dipole moment. So E bar equals to P into 2R divided by R square minus A square whole square into P cap. This is equation number 3. So here if R is greater than and greater than A, then A square term is very less than R square. A square is negligible. Okay, so then E bar equals to, so P into P bar, P cap equals to, P is the magnitude and unit vector equals to P bar, so 2R into P bar divided by, so it is when a square is negligible, so this is r power 4. Okay, since P into P cap equals to P bar. Okay, now R 1R and here cube, then E bar equals to 2P bar by R cube. So this is remaining term, sorry, here 1 by 4 pi epsilon naught. So here also 4 pi epsilon naught, here also 1 by 4 pi epsilon naught, and here also 4 pi epsilon naught, and here 4 pi epsilon naught, so then 4 pi epsilon naught. So then at axial line, E bar equals to 1 by 4 pi epsilon naught into 2B bar by R cube. So this is at C, at axial line, at a point, the electric field, okay, electric field strength due to electric dipole, E bar equals to 1 by 4 pi epsilon naught 2P bar by R cube.